Hello everyone, very good day. Welcome back to Intrinsic Intelligence YouTube channel. Today we are going to discuss on microservices design patterns. Particularly we are going to discuss on database patterns. Let's deep dive into the further discussions. So database patterns largely classified into these four sections or categories. So database per service, shared database across services, CQRS, command query responsibility segregation, and Saga pattern. Let's see one by one in detail. Database per service. This is the first database pattern. So the core idea is simple. Each microservices owns their own database. No service is allowed to interact or access it directly or indirectly. So only the access will be given to the owning database or service. How it works. Suppose we have order service, product service, user service, analytic service. Each service, order service will have its own DB called OrdersDB. It could be from PostgreSQL. Product service can own catalog DB. It could be from MongoDB. User service go user DB and it could be again PostgreSQL. Analytic service owns EventsDB and as per events, it can be any NoSQL like Cassandra or DynamoDB, etc. So each microservice will be referring only their own DB and there is no other service is allowed to interact with it. Suppose if a request needs a data from multiple services, each we need something called orchestrator or choreography. Those we will see in the later part of this video. Let's move on to the second shared database pattern. This is quite opposite to database per service because multiple services can read or write using the same database, often referring to same table or a schema. See how it works. So see here, order service, product service, and user service. All three points to the same single shared database. So this mostly we should prefer database per service, and if in case of converting from monolithic to microservices, in that case we can very well go for single shared DB. And this is a high level comparison of shared DB versus DB per service, the first two database patterns of microservice. So in terms of coupling, shared database is high because all the services are depend on it, so it will be a tight coupling. Whereas in database per service, it will be low coupling that is preferred. Cross-service queries. Suppose if the query has to be coming from different services and we are using so many joins in the monolith and we want to follow the same, we can go for shared databases and it is easy to maintain or easy to convert from monolithic to main microservices. Whereas cross-service queries such as heavy joins are hard in terms of database per service. How do we achieve it? That's the question. It could be achieved using CQRS, command query responsibility, or API composition, which we will discuss in the upcoming slides. Transactions. So shared database is simple asset, whereas database per service is like we should use sagas or eventual consistency. And deployment, it is difficult, and database per service, it is not that difficult compared to shared databases. So even for the technical choice, as I discussed, if it is from monolithic to microservices and the migration to should be happen quick and you don't need major changes at all, in unavoidable situations, we can go for shared databases. Otherwise, on the tech choice will always be database per service. Yeah. So operational overhead, the shared database is lower and then database per service is high because we are having many databases. That too, one could use Postgres, another could use Oracle, another could use Cassandra. CQRS, command query responsibility segregation. So here, this is a third database pattern. So what it does is split the read and write. So all the write called commands and all the read called queries. Instead of one model or service handling it, there will be two different models or separate services will handle this writes and reads separately. So this is how it works. When the command comes, command handler will write the DB. It could be transactional or normalized. And in the query side, query handler will handle it and it will be read model DB, normalized, optimized for reads. And how do we sync between both? We can use streams like PubSub. So once the write happens, it will notify the handlers. The fourth and the final database pattern is Saga pattern. How? It's like if we have a distributed transactions, uh, many n number of transactions need to work together, and then different microservices need to apply the database logic as well as business logic and return this pattern. There are two types in Saga pattern: choreography and orchestration. So choreography is no central coordination, and each service, once it completes, it notifies the other, so that all the services is complete, and then the transaction is marked complete, and then the request is sent. So basically each service listens to the event, and then once it completes, it produces the other event. So in the orchestration, there is a centralized orchestrator. Consider Saga orchestrator. So it will orchestrate the different service and produce the results. Basically, both choreography and orchestration will have compensating request, meaning if you are doing any transaction, suppose if you are debiting from a card and if the transaction fails in any of these, one of the services out of four, there will be a repayment or recredit to the service. That is a compensating actions will happen. And this is all about microservices database patterns. And thank you all once again for watching this video in our channel. Please do follow our channel, like, share, and subscribe, which will keep us motivated and give you more such thoughtful and knowledgeable contents. Thank you all and have a very good day.